Hello, this is a video on binomial probability and using the Mei S1 syllabus, and I'm going to use June 2010 question 6 to demonstrate this. This is the first half of a composite question, but it's a classic binomial, so I've used it for those reasons. Okay, let's start by reading the question. A manufacturer produces tiles. Okay, that's just context. On average, 10% of the tiles are faulty. Faulty tiles occur randomly and independently. So that's enough to tell us that we're in a binomial. What's true of a binomial? Well, each of the events is independent and therefore random, and there's some average probability that runs through the whole thing. Yep, so now we know it's a binomial. What questions are they asking you? They're going, a random sample of 18 tiles is selected. So from this point, we now know that we're looking at a binomial. So let's start by writing out what we know about this binomial. X is binomially distributed. And what do we need to have? We need to have our n value and our p value. Well, n here is the number of trials, which is the number of tiles, 18. And p is our probability. Well, they've told us that it's 10%, so that's 0.1. So we now know what our binomial is that we're going to use. So look at the Romans, part 1a. Find the probability that there are exactly 2 faulty tiles in the sample. Okay, so what's that asking us? Well, we need to be able to work out what our probability is we're calculating. This says exactly, so that's an equals, x equals, and it's 2 faulty tiles, so x equals 2. So the most important thing is to decode that. We've got 2 methods of doing it. Either we can use our formula now, and remember that our probability in our formula is going to be, what's our formula for one of these? It's n choose r, p to the r, q to the n minus r. So if we were doing the formula method, what have we got here? We know n is 18, 18 choose, well r is our value of our successes here, that's 2, 18 choose 2. What's the probability of a faulty tile? 0.1. How many tiles are we looking for? Again, r equals 2. That means that 0.9 is the complementary probability with 0.1. How many tiles are not faulty? 16 of them. So we could put that straight into our calculator, and the answer is going to be 2.835 if we do it the formula method. So have a quick look at our calculator method of using the binomials. Let's put that on the screen then. Okay, here we go. We're going to choose our distribution. It's the binomial distribution. We're interested in BPD because we're interested in a single point because it said x equals. I just need to set my data here to being variable. Number of successes, well that's our x value, that's 2. Number of trials here, 18. What's our probability? 0.1. That's our probability of a fault. Press the XE button, here we go, there's our 2.835 again. So that's pretty quick, isn't it, on a calculator for 3 marks? Okay, let's have a look at part B of this. Find the probability that there are more than 2 faulty tiles. Okay, so let's expand, give ourselves a bit more space. So B is the probability that the number of faulty tiles x is greater than 2. Well, we can either go through and use our formula, or much quicker ways to use our calculator. What can we get out of our calculator? We can only get out of our calculator a formula, a beat from the BCD. We can only get something that probability that x is less than or equal to some number. Yep. So let's have a look quickly. Draw your number line. We can have 0 breakages, 1, 2, all the way up to 18 here, can't we? What is the probability we're looking for here? Well, it said it's got to be, I'm going to put 3 there, so it's got to be greater than 2. So hey presto, that would be this probability here. Can we get that out of our calculator? No, we can't. What we can get out of our calculator is this probability to the left. That's the probability of less than or equal to, that's the probability of x being less than or equal to 2. Okay, and so we can go in our calculator and get that in a sec. And how does that relate to the probability we're interested in? Well, we're using the fact that the total probability is 1. So we're going 1 minus the probability of x is less than or equal to 2. Okay, so let's go straight back to our calculator. We need to come up 1 to go back. There we are, distribution, binomial, BCD, because we're looking for cumulative. All our numbers are the same, aren't they, here, because we're looking for x equals, x is 2, x is less than or equal to 2 is what we were looking for, isn't it? Okay, so we can press our XE button, and we've got 7, 3, 3, 8. So here we've got our probability is 1, sorry, minus, excuse me, let's make that clearer, shall we? 1 minus 0.7338, which is equal to 0.2662. Always can't quote your answers to either 3 or 4 SF in these in MEI. So there we are, that was the answer to part 2. How many marks did we get for that? We just got ourselves another 3. We're absolutely flying through now, aren't we? Because we just got ourselves 8 marks out in an exam of 72, is that? Okay, and let's go on and do our final part of the question. C, find the expected number of faulty tiles. Okay, that's C, expected number of faulty tiles. Number of faulty tiles. Here we go. Well, what's the expected number in a binomial? It's NP. And what have we got as our two figures here? Well, we've got N is our trial, number of trials, and P is 0.1. So that means we would expect 1.8 faulty tiles. We just got ourselves another 2 marks. So for about 3 or 4 minutes work, if we're working at full pace, we just got 8 marks out of 72. That's a pretty damn good return on our investment. Finally, here's my quick summary for binomial questions. What are we looking for to identify them? Well, they're going to tell you that the events are independent. Events are going to be independent. They're going to have the same probability throughout, and there's going to be a specified number of trials. That allows us to write our probability statement there, that X is binomial with N and P, and you'll derive what N and P are. On the individual questions, you will then be asked to find a probability. It's either going to be X equals a value, in which case in your calculator you're going to use BPD, or X is less than or equal to, in which case you're going to use in your calculator BCD. If you're in any doubt what you're putting in your calculator for a BCD calculation, go through, draw your number line out as I've done here, 0, 1, 2, 3 up to N, then cut it at the right place between the 2 numbers. So in this case that will be X is greater than or equal to 2. And then we're going to reverse that. So quite often that will be X is greater than 1, will be the other way of looking at it. And then if you're looking the other way, you're going to go for your complementary probability if you've got one of these cases. So you can find the green value from your calculator, the probability that X is less than or equal to R, and then you're going to do complementary probability, which is going to be 1 minus on the basis that the total probability must be 1. Hope that's of use to you. Good luck.